Great. Thanks, Mike. Yeah, we're just wanting to keep on schedule here. So our next speaker is Matt Gamel. He is a project manager with the Lower Columbia Fish Enhancement Group. While professionally Matt trained as a marine biologist, he grew up exploring the creeks and rivers of Idaho and Southwest Florida, and his love for freshwater led him to work with the Lower Columbia Fish Enhancement Group, where he's currently tackling large-scale beaver-focused restoration projects, including work to restore more than 10 miles of tributary along the base of Mount St. Helens. Matt lives on the Kalama River with his wife and their dog Hazel, and he enjoys spending free time working on their A-frame cabin, tinkering with projects and exploring wild places for fossils, mushrooms, and other nerdy treasures. Welcome, Matt. Glad to have you.
Thank you, Laura. I appreciate it. All righty, so I am getting myself queued up. All right, so I am going to be speaking about two projects today. The first one is a Stage 8 Riparian activation project that was done by my coworker and mentor, Bryce Crane. And the next one is one of my projects, which is on Mason Creek and installing these mega-sized BDAs for full valley inundation. So yeah, jumping forward. As I said, Bryce is doing the first project that I'll be talking about. Unfortunately, Bryce couldn't join us today. He is soaking up the sun out in Hawaii. So have fun out there, Bryce. All right, so this is Harrington Creek. Harrington is a perfect example of a lot of the creeks that we're dealing with, these incised, simplified channels that have virtually no woody debris or structure. They got the high banks, and they're pretty well locked into that kind of shape. Also very simple monoculture of alders and not much use for quality food for beavers and other creatures. Take note of the stump reference point there. You'll see that as the pictures progress. Okay, so the big takeaway that I want you guys to come away from this talk is that if you can fix the hydrology at a site, the planting and the riparian stuff will follow. Many of you probably have dealt with riparian projects where you've tried to get plants to grow in challenging substrates and tough conditions, and you can spend a lot of money, a lot of time, and end up with a bunch of stunted trees. And so this is one particular approach to try to ease that process, and yeah, we had pretty impressive results. So what you'll see here in the yellow are those high terraces, and in the pink are those what we call the spring germination zones. So a little bit of background, if you think about our key beaver foods, our cottonwoods and our willows, the seeds of those species have a very slim germination period. So they need to release their seeds in the spring, and those seeds need to land on consistently damp sand to be able to germinate. If they land on sand that's wet for a little bit and then dries out, there's a really good chance that a bunch of them are going to die off. The other factor is that all those pink zones that you see are really narrow slivers, and they're right along the margin where you're going to get lots of flow. And so in this current setup, it's really hard to get those species established because they just get wiped out every time you get a spring freshet or something like that. So, all right. So this is, notice our reference stump again. Again, unlike a Stage 0 project where you would go in and fill in the main channel and kind of bulldoze the whole site, Stage 8, you're reducing your impact. You're dropping down with equipment that high terrace. As Joe and others have referenced, in some cases you're using more of a process base rather than a low-tech. So this was an engineered big Tonka toy type project, but it very much engaged that natural process. Note that you can see the sand next to the creek is darkening up. It's very important that you try to get that soil right down to that damp layer. If you bring it down, it's just a little bit too high and it's staying dry, you're not going to get that germination impact that we'll see in the next slide. Okay, so as you can see, the whole site has it's sprung to life with growth, plants everywhere. We did a little bit of planting in here, but 90% of the plants that you see are all natural, came in on their own. As an organization, we're shifting our riparian planting approach away from trying to do like planting the whole site and focusing just on improving species richness. The other thing that I want to point out is a lot of people ask, why are all these logs up on the bank? They're not impacting with fish most of the time. That's really critical for all of those baby seedlings that are starting to get established. if you have a flood come in, you want to have some structure that can provide some sanctuary and protection to those seeds before they, so they can get that nice rooted base in place. All right, and then just a quick shot of what it's looking like in 2025. This is a fall shot, so obviously the leaves haven't come in yet, but super productive site. Salmon are coming back every year. Beaver are starting to plug up the logs, so definite success. And then I will have a quick 30-second video of some of Bryce's work on the South Fork Tootle. So sit back and enjoy. This was all last summer's work, by the way, so a lot of work. Bryce was able to buy an entire DNR timber sale and use all of the logs from that sale and put them directly into the South Fork Tootle. Nice. All right, moving right along. So jumping into Mason Creek. So we are terming these meadow makers. These are our mega-sized BDAs ranging from our smallest generally was around 100 feet up to about 200. And we've got another project coming up that are putting in all the way up to 600 feet. So very, very big scale. And I want to put a plug to Anna Branch. We worked with them on this project for helping go through the design work. Super great folks over there. Yeah, also reference a snag tree in the back. You'll see that pop up and give you kind of an orientation as this progresses. And yes, got to give credence to our original meadow makers, the beaver. All right, so Mason Creek, I kind of describe it as a little bit of my problem child with really amazing potential. So Mason is a tributary of the East Fork Lewis. It is a stream that, was a perennial strong flowing system, has a lot of cool elements, still has really strong salmon returns, but like a lot of our systems, it's starting to shift to drying up in the summer months and having big issues with fish strandings. Right now, the only areas that are staying wet year round are beaver ponds where the fish are squeezed into too small of areas, and a small portion of those are able to survive until the rains restart the system in the fall. This is the scale of the system. I'm going to speed a little fast. 2.5 miles, 250 structures. So yeah, this is a little bit of what we presented to our contractors to kind of break down the construction process. If you look at the top of the slide, the stage 1, this is kind of one of those critical components that I was a bit of a change for us that really worked well. When we tried to do big BDAs in the past, you deal with a lot of failure points. You've got undercuts. You've got what you don't see here are the dozens of beaver channels that are crisscrossing through this reed canary grass meadow. All of those are really, really hard to seal and create potential leak points. So if you're going to spend a lot of time building a big dam, you don't want it to leak. So we went in and we scalped that surface off. This is also, an invasive grass that we're trying to get rid of, ideally. Piled up that material on the side, brought in, sticks and woody debris, and created kind of a nice working surface to get things started on. This is obviously easier to do that this system was totally dry during last summer. We then went in, pound our post line, do our wicker weave, and then pack it with kind of this lasagna we were described of sediment, wood, which makes a nice strong structure. You can see that profile view on the side. All right, this is again just real world shots of that same process, the scalping. We did our post pounding with an excavator, huge game changer as far as time for driving hundreds of posts. We use a laser level to set our profile of our crest height for our dams, did the wicker weave with our crews, and then had an excavator come in and pack with that sediment. And it's super important to have that sediment component for sealing. Can't emphasize that enough. For engineers, this is kind of our profile view, showing again that taking down those high spots and simplifying the system. We did actually fill the channel in some cases. And then we've had it described sort of as a highly localized stage 0. So again, we're sort of that hybrid between an engineered type system and low tech, but with some pretty cool impacts. Very quickly touch on reed canary. We use it as a building material because it's already rampant through this site. You can use it to flood out areas of reed canary grass that you want to try to intensively kill. You do need about 18 inches of continuous inundation to drown it out. And you can preemptively scalp what will be the new margin of your pond to plant those areas so that you've got a better chance of holding it back from reinvading new spots. All right, so why go big? There's a perception, because a lot of our areas are degraded, that we see a lot of these really small seasonal dams that blow out, that is perceived as the norm. If beavers have enough food and stability, they can stay put in an area long term and build really big, stable dams. We're also going to get more with climate change and all the other stressors on these systems. We're going to get more and more creeks that are going towards the Mason Creek route and drying up, and you need big changes to try to reverse that. Same with if you can't bring it back, having larger functional pools can be really critical for those species to be able to have a sanctuary they can hang out in. Fire is another big one. Obviously, if you've got a huge wet meadow, that's going to be a much more functional fire break than a short pond and dam that really has a hard time because fire can jump over the top of it. Bigger floods. We recently had an atmospheric river move through here, and because that creek was able to get fully out of its flip, and use that full floodplain, it held up really, really well. All right, a little bit of just some examples here. Again, some of that environmental amnesia that we forget kind of what these systems used to be like. Again, beaver dams can be enormous. This is a half-mile dam up in Canada. One continuous dam is just monstrous. And then a different dam, which is the oldest dam, still standing, 125,000 years old. And just like beavers roll stones into the creeks, there's actually, they rolled woolly mammoth bones into the dam to help weight down their material. Just super cool example. So key takeaways. I'm sorry, I'm running a little bit late. So again, if you impound lots of water, there's obviously greater risk. So only install these big structures in areas where you've got a safe floodplain. You don't want to damage infrastructure downstream. That's bad for all of us trying to get these things on the ground. You want to install as many structures as you can. That redundancy adds better habitat as well as safety. You will need post-project maintenance, as was talked on a number of times previously. A big beaver dam in nature is going to be supported by a big beaver colony, and that's usually not going to be able to be done until you get that riparian response to feed a big beaver colony. So you're going to need human-based crews to maintain it for that first period. And then the big one, a lot of you guys, and I can touch more on this, is the fish passage side of it. Fish passage is not an issue just because you have a bigger dam. What's critical is how you incrementally stage up to the height of that dam and how close your structures are. You can make your water drop as big or as small as you want based on the ponding backup from that previous structure. And I can talk more on that if people want. So, all right. And then I've got a short video. Hopefully it doesn't take too long. There's that snag again. We cut our posts short. Could have left them a little longer. It makes it easier to weave. So pros and cons. We did have, so this site had not seen adult coho for at least 5 years. As soon as all of our structures filled in, they were just having a field day, chowing down on worms and easily making it over all of the structures. So really excited to see them in there. And then next year, we've got a huge project, as was referenced before, 10 miles out by Mount St. Helens, 500 structures. So yeah, very, very excited. Apologies for running a little bit over.
Well, good, Matt. Thank you so much. That's great talk. Those videos were just so illustrative of the impact and the changes happening through your projects. We really want to keep on schedule for those folks who may be having to sort of tune in and out and balancing other things in the background. So we'll be sure to have opportunity during the panel discussion to bring Matt and Brian and Ali into the conversation and hear more about what they're doing. So I'm going to pass to Mike to introduce our last speaker of our lightning round.